Solving quadratic equations using the square root method, part 2. And in this video, I'm going to be showing you 3 examples of how to solve quadratic equations utilizing that method. First, let's review the example that we did last time, which was x squared minus 81 equals 0. Following the steps, we isolated our variable, forced in the square root, which also forces in a plus or minus, and then we checked our answers. If you'd like to review how we did this one, you can go back and watch it on video 1. Moving on to example 2, we have the equation 3x squared minus 6 is equal to 0. If you would like to do this problem and all the rest of them on your own, I will welcome you to do that. Go ahead and pause the video. If you get stuck, I have listed the steps in the top right-hand corner. And if you would like to confirm that you have the correct answer, it is listed over there in gray below that orange box. Alright, solving this equation here. First, we must confirm that we only have one x, and we do that right there. So we can solve this one by using the square root method to isolate that x variable. Now actually, most of the time we can also solve these equations by using the factoring method that you learned last time. And this one factors a little bit. You can take a common factor of 3 out, but you cannot continue to factor. So you don't get very far in the factoring method in this problem, so you almost have to do this one by solving by using the square root method. Alright, my first step is to isolate the x squared. So I do that by moving the 6 to the other side. Remember, you want to add or subtract before you multiply or divide when you're performing opposite operations. That gives me 3x squared is equal to 6. To completely isolate your x squared, divide by 3 on both sides. Cancel out those 3. That leaves you with x squared on the left, and on the right, 6 divided by 3 simplifies to 2. So we have isolated our variable here. Now, to get rid of the square, we're going to force in our square root. Don't forget that also forces you to put in a positive and a negative. So putting in square roots on both sides of this equation, and then inserting the plus or minus that goes with it. On the left, the square and the square root cancels out, leaving us with x. On the right, we have both positive and negative. You cannot simplify square root of 2 at all, so that's how we leave it as our final answer. X equals plus or minus root 2. Remember, if the problem asks for the solution set, you enter the same answer, but you're going to enter it in braces. So we have plus or minus root 2 in the braces. So we have finished step number 2. Now, step number 3, let's check. First, we need to check that we have the correct number of answers. This is a degree 2 problem, so we should have 2 answers. And we actually do, even though it might not look like it. We can split this up as x is equal to the positive root 2, as well as x is equal to the negative root 2. So that confirms that there is 2 answers to this problem. Now we need to fully check and make sure that both of those answers work out the way that they do. So, going back to the original equation, 3x squared minus 6 is equal to 0, plugging in our solution set of x equals positive root 2 and x equals negative root 2. We need to substitute these in one at a time, so let me start with the positive root 2. And you just substitute this in for every place that we see an x. So we have 3 times my root 2 squared minus 6, and we want to confirm that that is equal to 0. Following our PEMDAS, we have to take root 2 and square it, which gives us just a 2 because the square and the square root cancels out. So when I multiply that by 3 and subtract 6, we do end up with the correct solution of 0 is equal to 0. So since that works out, that gives us a final answer. Now we must check the other solution of x is equal to negative square root 2. Again, we plug that into any place we see x in the original problem. Gives us 3 times my negative root 2 squared minus 6, and we're trying to confirm that that equals 0. On the left, the first thing we do again is our exponent. We have a negative squared, and negative times negative gives us a positive. And then when you take a root and you square it, those cancel each other out, so that leaves you with the positive 2. And of course, when you multiply that by 3, that gives you 6. So when you subtract 6, you do end up with 0, and that's what we were trying to do. So that confirms that negative root 2 is also a solution. So back up here to this problem, our equation 3x squared minus 6 equals 0 has the solution of positive and negative root 2. Moving on to my next example. The quantity of v plus 1 in parentheses squared is equal to 24. Again, we want to confirm that we can solve this one by using the square root method. And we can because we only have one variable, and that variable in a roundabout way is squared. So we can solve this one using the square root method. Now typically we want to isolate the variable, but we can't quite do that at this point. So the first thing that we want to do in this equation is we want to isolate the square, which is actually already done for us. So we're going to jump to step 2 here. To get rid of that square, we need to force in a square root on both sides. On the left, we have the square root of v plus 1 squared. On the right, we have square root of 24. And since I entered in a square root, I must also enter in a plus or minus. On the left, the square and the square root cancels out. That's why you did what you did. And you're left with v plus 1. On the right, you have plus or minus. Now this square root of 24 actually simplifies. You can do it using your good pi, bad pi methods that we learned a while back. Our good pi here is square root of 4, because 4 is a square. That leaves us with our bad pi of square root of 6, because 4 times 6 gives you 24. So simplifying that, simplifying your good pi of root 4, that gives you 2, and then just carrying down your bad pi of root 6. And then copying down the left-hand side of this equation. Now, our job to finish solving this is to isolate your v variable. Well, you do it again by performing opposite operations. So I'm going to subtract 1 from both sides of this problem here. On the left, that cancels out those 1s, gives us the solution of v is equal to. On the right, these are not like terms because one is a whole number and one is a root. So we cannot add them together, so we just have to write down what we see. A negative 1 plus or minus 2 root 6. So that is our final answer to this equation. Again, if the problem asks for the solution set, you put that same answer in the braces. Now let's check to make sure that we have the correct answer. And first, let's check to make sure that we have the correct number of answers. This is a degree 2 problem, and we have 2 answers. The first one being v is equal to negative 1 plus 2 root 6, and the second one is negative 1 minus 2 root 6. So we do, in fact, have 2 answers. Alright, now we need to fully check and make sure that each of these answers work out the way that they should. So going back to your original problem and substituting in your answers here. We can substitute them in one at a time. So let me start with the positive one of negative 1 plus 2 root 6. So substituting that in for my v in the equation gives me a negative 1 plus 2 root 6, and then that is plus 1 squared, and we're trying to confirm that this is equal to 24. On the left, your negative 1 and your positive 1 cancel out. That leaves you with your 2 root 6 in the middle, and that is still squared. Since this is a multiplication problem, it is okay to distribute that square. So that gives me 2 squared times root 6 squared. 2 squared is 2 times 2 gives you 4. And root 6 squared, the square and the square root cancels out, gives you 6. And, of course, 4 times 6 gives you 24, which is what we wanted it to be. So this solution checks. Now focusing on our other solution, which is negative 1 minus 2 root 6, plugging it back into the same original equation of my v, in this case, negative 1 minus 2 root 6, plus 1 squared. We're trying to confirm that that is equal to 24. On the left, negative 1 and positive 1 again cancel out, so that leaves you with negative 2 root 6 quantity squared. Almost the exact same thing that we had last time. So we can distribute this square again. First we have a negative 2 squared, and then we have a root 6 squared. Negative 2 times negative 2 does give me positive 4, and positive 4 times 6 does give me 24. So this solution also checks. So, solving the equation v plus 1 quantity squared equals 24, we have the solutions of negative 1 plus or minus 2 root 6. My last example, example 4. 2 times the quantity of v minus 7 squared minus 11 is equal to negative 3. First, confirm that we can do this using the square root method, and we can because we only have one variable squared. So our first job is to isolate the square here by adding or subtracting before we multiply or divide with opposite operations. So what we're going to do here is we're going to get rid of this 11 first. On the left, that gives me 2 times v minus 7 squared. My 11's cancel out. On the right, 11 minus 3 gives me 8. I still need to isolate that parentheses square. So my next step is to divide by 2 on both sides. Canceling out those 2's gives me z minus 7 squared is equal to 4. Now that I have my square isolated, I get rid of that square by forcing in a square root. And when I force in a square root, I force in a positive and a negative. On the left, my square and square root cancels out, leaving me with z minus 7. On the right, I have plus or minus, and the square root of 4 simplifies down to 2. To completely isolate my z, I need to add 7 to both sides. So that gives me z is equal to positive 7 plus or minus 2. Now since these are both whole numbers here, you must go farther. If you can simplify, then you must simplify. So we're going to split this up. The first one is z is equal to 7 plus 2, and that gives me the answer of z is equal to positive 9. The second one, z is equal to 7 minus 2, and that gives me the answer of z is equal to positive 5. So I have my 2 answers for my degree 2 problem. So I've checked that I have the correct number of answers. Now let's double check to make sure that each of these answers works out properly. Plugging them back in to my original equation, let me first start with z is equal to 5. Plugging it back in for the variable that we see. So we have 2 times 5 minus 7 squared minus 11, and we're trying to make sure that that is equal to negative 3. Following your PEMDAS, you have your parentheses first. 5 minus 7 gives you negative 2. Copying down the rest of my problem. Then your exponent, negative 2 squared, gives you a positive 4. And again, just copying down the rest of it. 2 times 4 gives you 8. And of course, 8 minus 11 does give you negative 3. So we have confirmed that z equals 5 is a okay solution. Starting with my other one, z is equal to 9. And again, just substituting it back into the original equation, plugging it back in for each time I see a z variable. PEMDAS, starting with my parentheses. 9 minus 7 gives me 2. Then my exponents. 2 squared gives me 4. Then multiplication. 2 times 4 gives me 8. And last is subtraction. 8 minus 11 does give you the answer of negative 3. So that answer also checks. So we have the correct answer to the problem of example 4. The answers are z equals 9, 5, in no particular order. So let's review these steps one more time in solving quadratic equations. Remember that it only works if there is one variable squared. If there's any other variables, then this method does not work out. So you do it by isolating the variable or the square, depending on how the problem starts out as. Then to cancel out that square, you square root it, and when you do that, that forces in the plus or minus. And don't forget to confirm that you have the correct number as answers, as well as if those answers actually work. So that's the end to solving quadratic equations using the square root method.